Let's take a look at rational exponents. Rational exponents are exponents that are fractions. If I take a look at 4 to the exponent 1/2 multiplied by 4 to the exponent 1/2, I can apply the product rule because I'm multiplying powers with the same base. So I can keep the base the same and add the exponents. Adding 1/2 and 1/2 gives me an exponent of 1, keeping the bases 4. If I look at the next line, I have the square root of 4 being multiplied by the square root of 4. I know that the square root of 4 is 2, and 2 times 2 gives me 4 as well. So comparing these two lines, I can see that 4 to the exponent 1/2 is really the square root of 4. So that means powers with unit rational exponents, and unit rational exponents are exponents that have a numerator of 1, really represent roots. In this case, this is a square root of 2 because the denominator is 2, but we can have the cube root of a number or the fourth root of a number if the denominator is a number other than 2. Okay? What if the numerator is not 1? Well, if the numerator is not 1, we can always rewrite it as a power of a power with a base raised to a unit rational exponent. So for example, if I have 4 to the exponent 3/2, I can rewrite it as 4 to the exponent 1/2 cubed, because this represents a power of a power, and we know that when we have a power of a power, we would multiply our exponents. So 1/2 times 3 is 3/2. So 4 to the exponent 3/2 is the same as 4 to the exponent 1/2 cubed. Okay. And 4 to the exponent 1/2 represents the square root of 4. So if we don't have a unit rational exponent, we can still rewrite it as a root. Okay, that's raised to the exponent equivalent to the numerator. Okay, so keeping that in mind, let's look at some examples. So this example here says evaluate without using a calculator. We have a 100 raised to the exponent 1/2. We know that the 2 in the denominator represents the root, so this would be the square root of 100. The base goes under the root sign. Square root of 100 is 10. Okay, the next one, we have negative 32 being raised to the exponent of 1/5. The 5, the number in the denominator, represents the root. So we have the 5th root of negative 32. So you're thinking of a number that when multiplied by itself 5 times gives you an answer of negative 32. That number is negative 2. Okay. You can check your answer with your calculator. There are buttons on your calculator that will help you evaluate that. Depending on your calculator, the button might look like something like this, or maybe something like this. It really depends on your calculator. Okay, let's look at the next one. Here, the base is a fraction, so we can apply our power of a quotient rule. We can multiply the inside exponents of 1 that are implied by the outside exponent 1/2 to give us 9 to the exponent 1/2 divided by 25 to the exponent 1/2. And then in the next step, we're going to rewrite both the numerator and denominator as roots. Both of them would be square roots since the denominators are 2. So we have square root of 9 in the numerator and square root of 25 in the denominator, giving us an answer of 3/5. Okay, in the next one, we have 16 to the exponent 3/4. This is not a unit rational exponent, but we know that the denominator represents the root, so this is the 4th root of 16, and that the numerator of my fraction would just go outside the brackets. The 4th root of 16 is a number that when multiplied by itself 4 times gives us 16. That number is 2, and 2 cubed is 8. The next one, we're going to apply the power of a quotient rule. We're going to multiply the inside exponents by the outside exponent of 3/2. So 4 will now be raised to the exponent 3/2, same with the 9. Rewriting both numerators, the numerator and the denominator as roots, we have the square root of 4 being cubed, and the square root of 9 being cubed. And the reason for this is because the denominators represent their roots. So since the denominators are 2, they represent square roots. And the 3 in the numerator goes outside the bracket. So square root of 4 is 2. Square root of 9 is 3. When I cube 2 and 3, I get 8 and 27. So the final answer is 8 over 27. In F, we have a negative exponent to begin with. So first we need to rewrite it using positive exponents. If I consider this as being a fraction with a denominator of 1, I can change the position of this power in my fraction, make the exponent positive. The numerator will be 1. So rewriting it using positive exponents, I get 1 over 16 to the exponent 1/2. Now rewriting the denominator as a root, I would simply write it as the square root of 16, since the denominator of my fraction is 2. Square root of 16 is 4. My final answer would be 1/4. For G, my base is a fraction and I have a negative exponent. So I can just take the reciprocal of that fraction and change the exponent from a negative to a positive. Now rewriting it as a root, I would write it as the square root of 49, giving me a final answer of 7. In part H here, again, I would consider this as a fraction with a denominator of 1. I'm going to rewrite it using positive exponents by changing the position of this power in my fraction. The numerator would be 1. The denominator would become negative 8 to the exponent positive 2/3. Rewriting the denominator as a root, I would write it as the cube root of negative 8, since the denominator is 3, and all of it will be squared since the numerator is 2. Cube root of negative 8 is a number that when multiplied by itself 3 times gives me negative 8, and that is negative 2. When negative 2 is squared in the denominator, you end up with 4. So the final answer would be 1 over 4. In part I, again, the base is a fraction, so I can take the reciprocal of the base and change the exponent from a negative to a positive. So it would become 2/3 is the exponent. Then I can apply the power of a quotient rule, raising both 27 to the exponent 2/3 and the 8 to the 2/3. Rewriting both as roots, I get the cube root of 27 squared over the cube root of 8 squared. Cube root of 27 is 3. Cube root of 8 is 2. When 3 is squared, I get 9. And when 2 is squared, I get 4. So the final answer is 9 over 4. Now some powers cannot be evaluated without a calculator, and you would need to use your calculator. You would need to determine what your exponent button looks like, and some calculators would have an exponent button that looks like this maybe, or something that looks like that. You would have to find it. Okay, so I'm going to show you how to evaluate these two powers here using your calculator. You would enter your base. So for part A, I would enter 10. And then I would raise it to the given exponent of 1.3. And I would get an answer of 19.95262315, which I would then round to 2 decimal places. So the answer would be 19.95. In part B, I would enter the base in brackets because it's negative. I would push my exponent button, and then for my exponent, I would put the expression negative 2/3 in brackets. So I would enter it as negative 2 divided by 3. And then rounding that answer to 2 decimal places, I get 0.27.